morning everyone, I am Ivy Quentangalin from Isabela State University taking up Bachelor's of Science in Information Technology. For this presentation, we will talk about data communication and networking. The objective of this presentation is to inform you what is data communication, what is data, and fundamentals and characteristics of data communication and networking and its categories. First, data communication. It is the exchange of data between two devices via some form of transmission medium. So, the process involved in communication system is made hardware and software. The hardware part includes sender, receiver, and that intermediate device through which the data pass. The software for part involves certain rule which specify what, how, and where used to be communicated. This is called protocols. So with the help of hardware and software, all the information can transmit from one point to another in the world. So this is called data communication. Now, let's tackle the 5 characteristics of effective communication. Number 1, it uses the same transmission medium and language. Number 2, direct and indirect communication. Mutual understanding and continuous process. And number 5, use of words as well as symbols. Next, what is data? Data refers to information presented in whatever form is agreed upon by parties creating and using the data, such as values or measurement. It can be number, words, measurement, observations, or even just descriptions of things. When you want to share a data between 2 or more computers, that is called as data communication. It is required to form a network between them. The effectiveness of data communication is depend on the 3 fundamental characteristics of data communication. Number 1, delivery. The system must deliver data to the correct destination. Number 2, accuracy. The system must deliver the data accurately. Number 3, timeliness. The system must deliver data in a timely manner. The data that is delivered late is useless. Next, a data communication system has 5 components of data communication. Number 1, message. It is the information data to be communicated by the sender to the receiver. Message in any kind of information. Number 2, sender. It is the device that sends the data message to the receiver. It can be a computer, telephone, headset, video camera, and so on. Next, receiver is the device that receives the message from the sender. It can be also a computer, telephone, headset, and so on. Number 4, medium. It is the physical path by which a message travels from sender to receiver. For example, it can be wire such as wired cable or wireless such as Bluetooth and Wi-Fi. Number 5, protocol. It is a set of rules governs data communication. Definitely, it is a regulation that used by sender and receiver to communicate in data. Next, let's move on to data representation. Number 1 is text. Text, it is represented as bit pattern. A sequence of bits pattern have been designed to represent text symbols. For example of this is ASCII, acronym example, BEACII, and Unicode and ISO. Next, number 2, numbers. It includes a combination of digits from 0 to 9. It is stored also a pattern or field. Next, images. Word 1,000 words in computer. It includes pixels. the number of pixels, also called resolution. Next is audio. It can be recorded or broadcasted. And next is video, a broadcast of data in the form of pictures or movies. Now, let's talk about the data flow, or what we call transmission mode. There are three types of data flow. Number one is simplex. Simplex communication is unidirectional. In simplex, sending device only sends the data and receiving device only receives the data. The example of this is radio or TV broadcast. Number two is half duplex. Each station can both transmit and receive, but not at the same time. If one device wants to send the data, the other device only receive it, and vice versa. But both devices cannot send and receive data simultaneously. It should be one at a time. Example of this is walkie-talkie. And last is full duplex. Both stations can transmit and receive simultaneously. The full duplex mode is like a 2D way street, traffic flowing in both directions at the same time. The best example of this is mobile phone through Messenger and other social media. Next is the network criteria. Number one is performance. It can be measured in many ways. Transit time. It is the amount of time required for a message to travel from one device to another. Then, response time. It is the elapsed time between an inquiry and a response. The performance of the network depends on many factors such as number of users, type of transmission medium, capabilities of the hardware, and efficiency of the software. Next is reliability. It is measured by the frequency of the failure, time it takes a link to recover from failure, and network's robustness in a catastrophe. And number three is security. How the network protect data from unauthorized access. The categories of network. Network is categorized with the following factors: the size, ownership, distance it covers, and physical architecture. Categories: local area network, or what we call LAN, usually limited to a few kilometers, or it may be privately owned and could be a network inside an office. Number two is metropolitan area network, or what we call MAN. An area network made up of all the networking large area, for example, the network in the entire state. So, it is larger than LAN. Then, wide area network, or what we call WAN. It is larger than LAN but smaller than WAN. It may compress the entire network in the city. This chart is the difference of size, ownership, distance, and architecture, and the example of these categories. The LAN, its size is building or campus, while the MAN is the city, while the WAN is the globe. So the smallest is the LAN, and the largest is the WAN, and between them is the LAN. So the ownership of these categories, in LAN, it is privately owned, and the MAN, it is public company owned, and the one it is private or public owned. Their distance is the land, a few kilometers, and man extend over entire city, and also the one extend over entire globe. The T architecture, the bus, star, and ring. Man, land to land, and one, man to man. Their examples. In land, the example is laboratory network, while in man, the examples is cable network, while in one, the example is the internet, which we are commonly use. Now, let's talk about network. A network is a group of connected communication devices such as computers and printers. It is a set of devices connected by communications links. Network is often referred as nodes. A node can be a computer, printer, or any other device that capable of sending and receiving data generated by the another nodes on the networks. The history of network. Middle 1960s, standalone devices. ARPA, Advanced Research Projects Agencies. DoD, Departments of Defense. In 1967, ACM, Association for Computing Machinery meeting. ARPA, or what we call ARPANET, IMP Interfaces Message Processor. In 1969, ARPANET Reality. 4 nodes. Number 1 is University of California, Los Angeles. Number 2, University of California, Santa Barbara, or UCSB. Number 3, Stanford Research Institute. Number 4, University of Utah. NCP means Network Control Protocol. In 1972, Vint Cerf and Bob Kahn, Interneting Project, Transmission Control Protocol, or TCP. Number 1 is encapsulation, or wrap the unwrap. Datagram, or UDP, it prioritizes time over reliability. Number 3, functions of a gateway, gate between two networks. Shortly thereafter, TCP higher level function. Number 1 is segmentation. Number 2 is reassembly. Number 3 is error detection. IP handle datagram. TCP or IP, Internet Protocols Today. Now, let's talk about the physical topology. It refers to the way in which a network is laid out physically. Its categories. Number 1 is the mesh. Mesh communication is point-to-point. Means the link carries traffic only between the two devices it connects. Number 2 is bus. Signals are shared with the backbone cable. On the other hand, bus is multi-point. It is one of the first topologies used on the design of early local area networks. Ethernet LAN can use bus topology, but they are less popular now. Number 3 is the star. Its signals are passing through the central device, means the devices are not directly linked to one another. Unlike a mesh, star topology does not allow direct traffic between devices. The controller acts as an exchange if one device wants to send data to another. It sends the data to the controller, which then relays the data to the another connected device. Number 4 is the ring. Signals are circulates within the network. It means a signal is passed along the ring in one direction from device to device until it reaches its destination. Here is the figure of topologies, their advantages and disadvantages, and their features. Mesh. Its advantages is point-to-point link. It is robust, it is privacy or security, while its disadvantages is it is expensive in cable and IRO connection, sheer bulk of wiring, and its future is N1 in connections. While the bus, its advantage is less expensive than mesh, is easy of installation, and its disadvantages is difficult reconnection, it is difficult to add station, and it is limited number of station, while its features is backbone cable. While the star, its advantages is point-to-point link, robust, less expensive than mesh. The only difference of star and mesh is it is less expensive than mesh. While its disadvantage is using central device. It has a central device. Its feature is hub. And then last, the ring. Its advantage is point-to-point link to both sides only. Easy to install and configure. While its disadvantages is unidirectional traffic of signals. The features of this topology is repeater. And that's it for today's presentation. I hope you learned